Hello?
Employee levels, snacks, blah, 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 blah.
Hello, hello, hello. Can you hear me?
Yep, I can hear you.
Okay, yeah. I can hear you. Yeah. Okay, I think you can share with me the recording later. What I think this tool will provide me the video too. All right, so cool. Thank you, Nestor, for this mock interview. So what we're going to do is it's going to be a mini interview in terms of the time. Instead of 1 hour, this time will be a half hour. So for the revision, if you're okay, we're going to just try to resolve one exercise. Is that okay?
Yep, it's okay.
Okay, cool. I'm going to share with you the exercise in culture. So, by the way, did you already select the language?
No, I don't have a language selected.
You can select it.
Oh, plain.
Yeah.
Right here.
You can just plain text.
Go with the JavaScript.
Okay.
There is.
Cool. Okay. So, I'm going to share this. There you go. This is the exercise.
Okay, no hints, no nothing. Okay. Well, I will read this problem, or you will read it for me, or
no. Take your time and read it, please.
Okay. Given a linked list, return the node where the cycle begins. If there is no cycle, return null. Okay. The first thing that I understand right here in the first sentence is I have a linked list that has a loop into this list, into the nodes, the list. I need to return the first node where the loops starts, but if there's no loop, I will return null. To represent a cycle in the given linked list, we use an integer positive. That post is positive.
Yep.
Which represents the position, zero index, in the linked list where the tail contents. I will read the line right here. I don't know what. Okay. The linked list where tail contents to. If position is -1, then there is no cycle in the linked list. No, do not modify the linked list. Okay, I can't modify the linked list, so the values cannot be modified.
Exactly.
Well, to represent a cycle in the given linked list, we use an integer positive which represents the position and the linked list where the tail connects. Okay, I don't understand this sentence. I think it's not part of the problem. But
yeah,
I have to ask you.
The point is that you have a linked list, right? And you have a cycle, right? So at some point, instead of receiving a null and getting the tail of the linked list, you're gonna start in another position in the middle of the start. It depends of the linked list. So you will never end that, right? So the point is for you to get what is exactly how to identify where is the root of the cycle.
Where is the root of the cycle? Okay. So I am writing an example right here where, let's see, points B. Node E points to node B. So this is the node B. So we can say, okay, here's the root of the cycle. So, and this is the tail right here, the node E. But to represent a cycle in a given linked list, we use an integer positive which represents a position. Oh, okay. Given a linked list, return the node. Should I return a node or the index or the position in the linked list? Say in this is an example, the index is 0, the index is 1, the index is 2, the index is 3.
Exactly, correct.
And the index is 1. So I will return the index, the return will be 1.
Correct.
No the instance of the node. No the memory, the pointer memory of the node, right? You are looking for the index number 1.
Exactly.
Okay. Well, now I understand this part right here. So if position is -1, then there is no cycle in the linked list. So I'm getting trouble with this proposition right here because the problem says that if there's no cycle, return null. But here it says if position is -1, then there is no cycle in the linked list. Understand it.
Well, it is just a way to represent the linked list in terms of index, and
Okay.
it's just suggesting that if you find a position -1, then that could means no cycle in the linked list, right? But,
okay. Yeah.
That's all the point.
It's a way to see the solution.
Correct.
For the problem. Okay, got it. So note, do not modify the linked list. Okay. So I will write a function right here. Well, I don't start with that function. I will start with how I'm going to solve the problem. So because code is not the best thing to do first. So I have this example right here, and I will write another example right here where there's no cycle in the linked list. So I need to ask. So this linked list is a single linked list or double linked list?
No, it's a single list link. Just one
Okay,
direction.
single linked. Okay. Well, saying that, okay. How can I achieve this problem, or how my approach will be? Well, I have this list. I will traverse this list from the first node until I have a null node. This will point to null. So once I see there's a null, that means that is the end of the list. But on a cycle or on a I will never see a new pointer. So this will never end. Imagine I have a while right here where node next equals null. This condition will never happen. So I will never break the loop, and I will have my trouble right here. So this solves a normal regular linked list.
Correct.
Okay, but we have this problem right here where E points to node B and V is before that node, or we can have that E pointing to E. This is the loop right here. So let's say it's B. So I need to check if I visit the node, I can storage the value, but I need to ask, the values in the linked list will be all unique, or can I have repeated values like CC, like this?
Now, at this point, we can assume that all the items are unique, but the pointer the pointer from one node could point obviously to another unique value, so that becomes the cycle.
Okay. Having this state or having this constraint, if I will write my constraint. Oh, we have constraints. All values are unique.
Mhm.
Well, this give me a I can use right now. I can use if all the nodes have a unique value. Now I can use a hash table or map, something like that, where I can storage the nodes that I have visited in the past. Let's say, okay, next is not null, entonces that's what. Then directory node value. I will say I will start two just to have a value right here, or I can use a set from JavaScript. I can do this add, and I can storage those values. Node value right here. Before I do this, I need to check if there is a value in the set. If this value already was put it on the set. So I think I can solve this problem with a algorithm on O of n, where n is the number of nodes. Plus, I can save right here the index. Let's say A have a index 0, and B have index 1, and C is index 2, and so on. So I think this solution right here using a hash tables can solve if I have a cycle in a linked list. So, but this is time complexity, let's say TC, but it will take O n of memory complexity.
Okay.
So I think there are some approaches or there are some solutions that can take O1 memory, but I'm not sure that I can solve this in less than O of n time complexity, because I can have this linked list, so I need to visit all of the nodes. So,
yeah, that's correct. Mm-hmm.
So I will keep my solution with this. So the steps, I will write the steps right here. Move my mouse. My steps will have the function. The input will be a node or the root of the linked list. So the first thing that I will check is start a loop. Start a loop to visit all nodes right here. The next thing is check if the node is already in the directory or map. I will use a map because I want to storage the index of the nodes.
Okay.
If there is, say this, if exists, return the, or break, that was a break, the loop, and return the index right here. And if there is nothing in the set or in the map, it's add node to the map. Okay.
Mm-hmm.
And after that, if the loop ends, so I will return. I will say no right here. Storage. Restore the index. And I will say right here, return the index. Because I just finished the loop. I traverse all the list and I have nothing. And I see nothing. I see no cycles on it. So,
just remember that you need to return the actual node. The index is just a representation.
okay, yeah, okay. Oh, good.
Yeah.
I can storage the node. Yeah. Turn the node or node. So that will be my steps. This is using a map or hash table. That's why I ask about if all the values are unique. If all the values are unique, this data structure will give me a better time to look if I have a node on a directory. Or yeah, I think there's another approaches or there's another solutions using the runner. I think is the technique where you have a fast index where you have a slow index to the node. Let's say you will start on node 0, yeah, but the next will be on the 1, and the fast pointer will point to C. And after that, when in the next loop, we will point with a slow pointer to C, and the other will jump by 2 until E, and so on. And once will be an intersection in the pointers. Maybe that say, okay, there's a loop, but I'm not pretty sure if when these two pointers get the intersection is the start of the route or is the start of the cycle, because maybe they see each other on E, but I'm not sure that this is the route.
Okay, you're saying the technique of the pointer, right? So one slow and one faster, right?
Yeah.
But well, with that technique, I think you can check for the cycle, right? But think about
just for the cycle, but not for the root of the cycle.
Think about how do you actually identify that there is a cycle with that technique?
With the runner technique, with the slow and faster.
Yeah.
Well, that technique, I know that exists this technique, but I'm not pretty sure how it works. on this level.
Okay.
I need to study more about it. I think, and this is saying what I think, is there will be one time when they point to the same node. Let's say pointer 1, pointer 1 equals to pointer 2. This is on memory, right? Not on the value. Maybe I can say on JavaScript is like this. I don't know. I'm not pretty sure. So I don't use this technique at the start because this is, or what I know about this technique is the pointers of the memory. They pointing to the memory. So I don't know how to point memory in JavaScript.
Okay. Okay. Well, even without that, could you just try to explain me, maybe with that example or other example, if how you what is the result about getting or identifying a cycle with that technique? Is that possible for you? Or
Okay.
do you prefer to proceed with your other solution?
At this time, it isn't possible for me because I don't really know the runner technique in the deep. I know exists this technique, but I need to study more about it. But pretty sure exists that if I check for a couple of hours or maybe a half hour, maybe I can try or I can figure out how it works and how to implement it. But by memory, I don't remember how this technique works.
It's okay, don't worry. Then, what is then your approach? Are you going to use the hash table approach, or hash sensor? Okay.
Yeah, hash table. I will use a hash table to solve this problem. So I know it will take more memory than I can have an algorithm with all of one memory, but this approach is this because I will copy literally. I will copy all of the values in this in this hash table. So I can write some code about how to start a loop. I have this while right here. So this is the start of the loop.
Could you create a function in order to see
for sure.
What is the input and what is the output?
Cycle. The input will be a node. That means this is the root. Saying that nodes have this structure. Node have values and next. Start the loop if node next is null, or maybe there is an empty. If it's an empty list, I have null on the root. If it's not null or has value and node next equals to null, so this will break my loop. And then check if the node, okay, I will create right here. Let me then right here. This will be the function, so maybe I will put some jumps right here. And the first thing is let map can be a constant, const map, and new map right here. So check if the node is already in the map. Okay, map has a function that will check if node value exists on this. If I think I missed this is right here. If the map has the value on it, so that means that this is our cycle. We find the first or the root of the cycle because we already visit this node. So I will create a node. This will be loop node or root cycle node equals to new right here. So right here will be map I think there's a function right here. I think it's get because it has that set function. I will use the get function and in the node that value right here, and I will break the loop. This is this f right here. It exists. Break the loop and start the node right here. Then to the map set or add. I think it's add. This is not the I know that there exists some function that give me the node or give me the value by or give me the inner value by the key. This is the key. The value will be the key.
Yep.
So I will add node that value. This is the key, and the second thing is the index. So I will need a index right here. Let index equals to 0. Index right here, and every loop I will increase this index. I will take first the value, and the first round will be 0, and next will be 1, 2, 3, and so on. So this is the alpha node right here, and then I will set my node to the node that next. Whoa, next right here. And the last thing is return the root cycle node. And this is the end of the function. Return the actual node of the root of the cycle or null. I will put this right here because if I found nothing on this loop that can do this if on true, I will have the default value that is null. So I think this function right here will solve the problem.
Could you evaluate or test your function?
What do you say?
With an example. Could you evaluate your function? Test your function?
Yeah, sure. I will take this example right here.
Okay.
What I did? Let me take my example. Okay, right here. So this is an example right here where there is a loop because points to C and so on. Well, first the root node is A. So I will have A right here pointing to the B as next. So I will break this right here to give it less loops. I will create a map this will have this value at the start, and an index that have 0, and a root value that has null. Okay, the node has value, yes, is an object, and the node x is equals to null, nope, has another node. Okay, we'll enter into the while loop. Okay, map has a node value, has a key with a, the value of the node is a. No, doesn't have any key that matches. So this right here will add into this map the a with the index 0, and then the plus plus will increase the 0 to 1.
Okay.
Like this. So node is node x. Now the node points to b, like this. Oh shit. Now this is my new pointer. So we'll erase this. So, and then b has value, yeah, has value. And node next is equal to null. Oh, it's different from null. Damn. There it is. I had a look right here. Because I wanted to keep going if I have a wait.
Yeah, that's correct.
Yes, this is not a tail, right? Okay. The same thing right here. The key A is in the map, or the key B. This is the key. The value is the key. So as the value in the map, no, we'll repeat this. So this is B with 1 because I have the index 1.
Sorry, Nestor, but we run out of time for now.
Oh yeah, for sure.
Yeah, it's okay. My last question before leaving is that could you identify edge cases for this function?
The edge cases, yes, because let's say we have a really long values. That would be a problem.
Why do you think a long list is a problem?
What?
Why do you say that a long list is a problem?
Oh no, a long list is the problem. A long value on each node, or maybe if the nodes are pointing not to values like this, maybe they are pointing to some memory, like say 0x or 0x, I don't know, something like this, f or something like this. This maybe will be a problem because we are pointing to a memory. So I know this works if we have this kind of list, but it will not work with another type or really long values into the nodes. Maybe for storage numbers or single characters or not really long strings can work very well, but I think this approach is not for all the cases.
Okay.
Or imagine you have a really long list. Maybe this list could take, I don't know, in memory can take 2 gigabytes. So if the list take 2 gigabytes in RAM, this will be a problem right here, the memory complexity. Because I will need another 2 gigabytes for storage the directory.
Correct. Okay. No more questions for now. I think we can stop right here. Well, the feedback will be available in a document for someone that would like to know it. Thank you, Nestor, for your time. See you in the next one.
Yeah.
You can record. You can stop the recording now.